Okay, today's date is the 10th of 3rd, 2026. The time now is uh three precisely 3:29 p.m. So let me get this computer down here. Let me do my work here. So it's my desk. The desk of Nante Michael Wala. So today I'm trying to do some computation over my sparse lattice framework, but I'm trying to model it properly, computationally, of course, done properly. So I'm sitting down here, I'm just trying to get myself together. So my bank account stuff. Let's see that shit here. So it's for me to do later. Just look at something. So basically, what much to do? So today, I want to introduce myself as me, Uche, you from myself, me myself, and my art. India, me myself, I. So I'm a framework of unilateral computing. So what is unilateral computing? What is it? So unilateral computing is a measure of computing consensual space and time. What that means is literally, so you're gonna have permission, consent, and you have consensus. Now, if a program gives you permission, gives you consent, you're running the program already. If you need permission to run the program, you have to enter Y. Type Y. Do you give permission to give consent? Now, why? Now, consensus is unilateral. Now, consensus is unilateral. So you need do you need more time to give a permission? Do you need more time to have consent? And do you need more time to have consensus? But you enter the model in unilateral system before you unilateral consensus. Unilateral consensus is basically the consensus of unilateral consensus, like a system has to be consensual. Unilaterally, consensual gives you permission to do stuff based on space and time. The memory allocated ahead of time on the fly memory allocation as you type in the keyboard and on the fly when you do it. So the math is basically a model. So I'm going to start with a model first. And the model I'm going to do is this. So my model is, oh my computer's fucking, my model is this. It's basically too bright, but it's kind of just, my model is this. My model. So my own model is unilateral computing. So basically, you're going to have, doesn't matter if you are, yes, do you give permission? Do you give consent? Do you give consent? And the program, if you, do you give consent? Yes or no? Yes. Now, yes, yes. Now, if you type in Y, or yes, the computer starts to run. Now, consent will have give you more space, give you triple the space and triple the time allocated to this triple space time, three times space or time. But these are auxiliary components. These work in step supervision. Think of them as quantities of space and time, like a graph. Let me try and use a degree of so you can have an A star graph model, A star, which is shortest path or shortest path graph to your next system. So you're gonna have everything up within a halves. So if I have this in a half state, you're gonna have half done and half not done, representing the completion process or the granular completion system. So why does this matter? Think of a bookshelf. A bookshelf. Now that bookshelf contains all the books. Unless you have 20 books. 20 books, 20 books. Now, 20 books in the universe, you have a space of 20 books. That means you have to, and you should have some. The system is a height 5, with 4, so it's rectangular. So you're gonna have half 5 times 4. 5 times 4. 5 times 4, what is 20? So you're gonna have 20 books. Now, 20 books of 5 times 4 equals a memory. So a memory allocation is either let's say so you're gonna have five books. So you're gonna have for every row you're gonna have 5 books. For every row you're gonna have 5 rows, and I'm trying to work it out as a model. 5 times 5 rows. You're gonna have five. We're gonna have 5 rows per one book set. One books, like one category of books, like in a normal bookshelf. Let's say given example. So, let me just see what book I was saying. Philosophy. So you're gonna have philosophy. You have art. You have philosophy art. You have music, you have geography, and you have geography, and you have physics, physics. So 1, 2, 3, 4, 5. So you can have 5 books there, but these are categories of the books. So the goals to have the system unilateral. So this system does not get enough. So you're gonna have a MuCO boot sequence, like a triangle that makes it unilateral. So you're gonna have any space and time in this one. For example, the MuCO boot sequence has 3 axes. So you're gonna have basically the MuCO boot sequence work on triangle. So you're gonna have half, half something north, half something pointing north, polar north. So this is basically pointing longitude, latitude, longitudinal. So you can have a pointer longitudinal, latitudinal. I'm gonna just basically north. I'm gonna have something pointing orthogonal north. That'll be in a half as well, in a half state of latitudinal, longitudinal, but this is like a clock manner. So you're gonna have 3 tridents. I'm gonna have something pointing a half or quarter, I don't know. A half altitudinal, basically this is the altitude. This would be altitudinal, longitudinal. This is altitudinal. Let's call it altitudinal. This is altitudinal. So you're gonna have 3 tridents. They're called tridents. And this is not a polar. So if you think of the Earth's poles, but don't worry about that completely. It's good to have a space and a time. You always have, but you never have to. You never have to hold. You have something. Listen, you have some space. So basically, the unilateral space is consensual. It's like your own living quarters. You have this space, but you never have to physically hold it in memory, hold it in space, hold it in space, or hold it in time, because it's consensual, hold it in time. So that's the goal. So the trident, the MuCO systems normally, so the algorithm for the trident boot sequence is what has to resolve the system, and you have to determine the every pathway and shape you go, every path. There is, so there's a way to do calculus. We use summation notation that does this. But I'm going to do my the goes to have this computed. So the problem with this bookshelf, back to the bookshelf, is that the books are, if you own this bookshelf, you have more knowledge onto the bookshelf, and the more knowledge you have onto the bookshelf, the more you know, and the more you can lose, because the bookshelf. If you have 20 books, if you have 19 books, 20 books, you need another. You need that's one, and then you get one bookshelf. One bookshelf has five, 4. So you got 2 bookshelves, 20. So let's say you're doing one bookshelf, and you're gonna have this house. You're gonna try to try the so once you get one bookshelf, one divided by one 120 over 20, 1 over 5, 120. You have a proper function 120 over 20 will be so if you have 20 over 20, so if you do 1 divided by 2 of 20 over 20, equals to 1. Oh, I'm wrong. Yeah, 20 over 20 is 1. And the 20, because the bush rule, you get 20, 20 over 20 is 1. If you do 20 over 20, 1 divided by 2, or 20 divided by 20, 20 divided by 20 divided by 2 will be equal to 20 divided by 20 times a half, and that will give you 20 over 40. That will give you a half, so times 2. That will be 2 over, you have to flip the fraction, you have 2 over 1. 2 divided by 2 is 40, and 2 divided by 1 is 20. So you're going to have 4 divided by 2 is, 4 divided by 2 is 1. 1 half. So you're going to have KFC. No, keep it, if you divide them. So if I'm times them, I keep the sign, I flip the fraction, and I change I keep the sign, so I keep the sign, KFC, keep the sign, flip, this is basically math I'm doing, flip the fraction, and change the sign. Yeah, so that'll be 20 divided by 20 times 1 half become, keep the sign, flip the fraction, 20 divided by 20 times 2 divided by 1. Now, change the symbol, change the, keep the sign, flip the fraction. So that'll be change the 20 times 2 is 40. 20 times 2. 20 times 2 is 40. 20 times 1 is 20. So 40 divided by 20 is a half. So the simple function, so the KFC model, I don't even know what the C stands for. But you know, I think I know somewhere if I remember my video or something. 4 divided by 2 is 1. 2 divided by 2, so 2 goes into 2. 2 divided by 2, 20 divided by 2 is 2. 2 divided by 1. And that was 2, 1, 2 to the power of 2, 1. So you're going to have fraction 2, 1, 2, or vector 2, 1 is a model I'm using. 2, comma 1. Determine the vector. So for every rotation I do, a 2 to 1 rotation. And you know, I never have to hold the space and time. I can just operate. So you get a vector 2 over 1. Let's go to vector this is a vector A. Now A is a 2, 1, and it shows that here this for me to have consensus, you have to have a ratio of 2 to 1 to something. I don't know what I'm saying here, but you know the trident has to resolve the system in a half. So you're gonna have a half. So if you don't know MuCO, so the MuCO system. So if I have if you model this as if this becomes a linear system, so if I take all these books, is that all these 20 books and line them up in all the combination, I can line them up. So listen, if I have them lined up, so if I have all of the books in the middle, so the so listen, A is 2, so the lateral compute is 2 divided by 1, 2, comma 1. So this is lateral vector. So anything that uses this vector computes over 2 over 1 of any system. 2 over 1 times 5 over 4, or 4 over 5, you know, or 2, 1, comma 5, 4 over 5. Let me try and do that. So let me do cross product. We use cross to do cross. So you're gonna have 2, 1, column vector 2, 1, and times 5, 4. And that will be the unilateral system for the x, y, z coordinate system. So that'll be 2, 1 times 5, 4, and 5, 4 is a column vector and a row vector, and the row coordinate will be 4, 5. So that'll be 2 times. So let me try to work this out. That'll be 2 times 5, which is 10. 2 times row, 2 times 5 plus minus I don't know. 2 times 5 is 10. So basically, the transpose of 2 times 5 is 10, plus. 2 times 5 is 10, plus 2 times 4 is 8. It's 18. And you're gonna scroll down. So 1 times 5 is 10. So basically, you're gonna expand the vector 1 times 5. This would be a vector because it's a cross multiplication performing. So cross multiplication, you have to rotate. So if you can do so, let me do the problem. So you can have it transpose. Let me try it down. So I'm doing some problem. I've got one problem. So you got to so you're gonna have basically to go to align the MuCO system. The MuCO system again works by aligning everything onto an axis and finding the common middle and determining what is the space you can perform the operation on. Because the space is basically the A star marker. So you have so you're gonna have the first one. You're gonna have the first. So the algorithm works like this. So let me give you the overflow of the algorithm. So the algorithm finds central part. You're gonna have all the books. Let's say all the kind of philosophy A, philosophy B, philosophy book one. Basically, you're gonna have the 5 books. So the 5 books can do them in chunks. So you can have all the space mapped to a system of the ratio. So you have 20 books there. You have 20 books. So 20 books to one bookshelf, and that 20 books has a set. Like you have if you start from the row, you have let me try to do it properly. I'm not even doing this right. 1, 2, 3, 4, 5. 5 column 4. If you start from the row, so the row is 5. Row conjugate is 5, 4. And if you go to the column, it's column vector. Column, so the row vector defined by m is 5, 4. The column vector divided by n is 4, 5. And the 4, 5 is a matrix. So the 5, 4 and 4, 5 is a matrix. It's a vector. It's a vector. So these are 2 vectors of the books. So the books have to align. So the books are just components. They don't numerical. They mean something. So the books are literally alpha, like alpha numeric. But there are things you have to process. So it doesn't matter if you have. So you have to create a map of this system. So the map will be the kind of from here you go from book A in philosophy to all the way to book basically, if you start from the row, book M is a row. Book N belongs to the row. This is book N. N is basically the basically book N is the column. Is the column. The column belongs to the column. So the column equals to N equals to 4, 5. And the row equals to 5, 4. And that's what we call n and m, variables n and m. But you don't have them unilateral. So you can have them in a way that doesn't affect this. You can have to have the A star one. So I can't know to do A star paper, but the A star one is what's used. So you're gonna have the shortest part between all the books because you have to index them alphanumerically. So, for example, if you have, let me write down some books, books names I don't know. Philosophy. Let me try to write down some philosophy books because it has to be done, guys. It has to be done by me. It's my work. So, 5 philosophy books. 5 philosophy books. Philosophy books. Philosophy books. Greek. Why Plato matters now? Because it's really so let's just say A to A B C D E. So basically, let me not use the name of the book. Let me use something else. Let me use A to F. So you have the addressing itself. So you can have the memory addressing of books. So you can have 5 books. Books are books are numbers, double digits, and they have let's say you have 0, 0 at the bottom, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and you have A0, A1, A2, A4, A5. Yeah, so you're gonna have a system of that. So no, 0, 0, 0. No, this is 0, 0. Imaginary. I didn't know what to do it probably, but I'm trying to, let's say I want 0, 0, 0, okay. Let's just say it, because I'm trying to give, I'm going to go model in my head, but it's not really that hard. You're gonna have A0. You're gonna have A on the A, B, C, D, E, A, B, A, B, C, D, E, A, B, C, D, E. But these are just alphabet, so alphanumeric. So you're gonna have A, B, C, D, E, A, B, C, D. I feel like a baby. Ah. A, B, C, D. I can have A, 0, 1, 2, 3, 4, 5. So you can have A1, A2, B3. Basically, you're supposed to have alphanumeric indexing, so you can have the books have a tag, and a tag is basically what you use to rotate the system because the system has to preserve the trident rule. So let's pick any set of three books, any set of three books. I'm gonna pick A B3, B3, AB3, B6, and D4. Three books. So three books here represent things like the lattice, but the lattice is basically this way. So these are three books I have. So these books I have, I can show. I'm about to show these three books are in the set of the row and they're mine. So it doesn't matter where I have it, it's consensual and the single can verify them. So this space I hold this space, I have this area of the space. You may think that B2, so basically this alphanumeric, so basically hexadecimal, so it's a really hexadecimal system because my book is not literally you're supposed to have the bookshelf expand via the system of hexadecimal, but this is just A B C D and 1, 2, 3, 4, 5. So you're gonna have the row. So you're gonna have B. So the book. If I have three books, B3, B6, and D4, I can compute over the spaces via hexadecimal English system. I can probe the system via code via the A to F 0 to 9 codec. But this is a hexadecimal code, and this is hexadecimal. So basically the trident resolve this by mathematically. Like, if I face north, if I'm facing north, if I start from book B3, and I'm polarized B3. So if I start from B3, I actually polarized, and I'm going to B6. Is there a pathway you can go to B6? Yes, I can go from to B because B, I'm reading on the path B, and 6 is just 3 units away. So that's three units away. North. So I come back north, and I check, is this path clear? It's clear. So is this path clear? Yes. Can I go further? Yeah, I'm done. So basically, three north and D4. So basically, D4 will be I have to go to the fourth quadrant of A. So the fourth quadrant will be A sub 4. This is the fourth will be on the latitudinal scale. So basically, it's basically not to basically the unilateral systems are not loading systems. They're not load. You can't load anything there. You don't load this system. This is already in the address. But it's like basically it's called basically you got linear probing and you get quadratic probing. So you get linear. So basically it's a form of linear. It's not linear probing per se. Because linear means it runs in linear terms. You have to replace them. But it's called dynamic probing. So the systems are unilateral, so dynamic. So I can't do the math because I'm down. but it's new math. I'm pretty sure. So you get B. So if you start from B, you have B1, B2, and you're only looking at observe. You only what you it's a full measurement of system. So you can have can only use a half a full measurement of system. So to find something, so it's not to long system, you have to have it in the half of the spectrum. So it will be B3, B3, times a half. So B3, B6, B3, and B6 times a half will give you the half measurement. So the half the half of something. Get half of something. So half of a read write ratio. If you open half of write, you need half of read. So you understand the half read and half write. For example, say the half of full read is if I want to do a full read, full read, I have four writes and two reads, and this half will be half of read and write will be uh, two two writes and one read. And this is half. So you need to so it doesn't lock. It does not lock. No. Two times two is one. Two times a half. No, half of two. Half of two. Half times two is one quarter. So one quarter read will be one half read. One half read. So one half read operation will be one quarter. One half. 4 divided by 2 is 2. 4 divided by 2. 4 divided by 2 is 2 reads and one quarter writes. Right. So basically it's a dynamic problem system. It's really like a hash table little problem. But it is dynamic. Oh my days, my computer. It is dynamic. My computer froze, mate. Oh no, my computer froze. I can see my video. So it's meant to measure the kind of the A star degree center. I've been saying that, but I can't do it. Basically, you have to understand that you have to organize in this kind of structure first. That is polar, opposite. You gotta have up, down, left. If you have up, you have down. If you have left, you have right. If you have charm, you have strange. And this can be computed over the mean, mode, and median of the system. There we go now. Oh my days. My computer's acting up. So that's the goal, guys. To unite your computing system. Especially you have to hold but never share. You can hold but never share. So basically, my computer was acting up basically. I couldn't trust it. I could have done it for qualification there, but it's an alphanumeric injection based on the codec, wasn't the hexadecimal codec. So the goal to have the system like doesn't matter how much books you have. There's a common center for this book, and that common center is your space or time. If you think everything about it, but everything was the trial to have some. Trial has to when the trial space, it's polarizing to you. MuCO book sequence, so it's polarized to you. So come in the middle of the MuCO book sequence in the show, but it's polarized to you. It's polarized to your space, so you don't have to share that memory, share that artifact, share it. It's basically security by design, but it gives you because you have space allocated to you. Some kind of take that space away. That's unilateral computing because it doesn't. It's not. It's basically consensus you don't need to share. Consensus you don't need to share.